Hello and welcome to another video for Calculus 1. In this video, we are going to discuss about three things. So the first one is we'll use symmetry of a function to evaluate integral. The second one, we are going to look at the average value of a function. And the third one, we are going to look at mean value theorem of integrals. So the first theorem that we have here is integrals of even and odd functions. So we'll use even and odd property of a function to evaluate an integral. So the theorem states that let a be a positive real number and let f be an integrable function on the interval on the closed interval negative a to a. Then if the function f is even, the integral from negative a to a of f of x dx equals 2 times the integral from 0 to a f of x dx. So this basically means let's go ahead and draw a function here. So as we know that an even function is symmetric about y-axis, so the graph of the function looks something like this. Now if we are integrating from, let's say, negative a is here, and let's say a is here, since this function is symmetric about y-axis, the area on the left, this area right here, equals this area here on the right. So instead of integrating from a to a, we can just integrate from 0 to a. So we'll take this area in the first quadrant and then multiply by 2. That's basically what this says. So the area from negative a to a equals twice the area from 0 to a. So that's for the even function. Now, if our function is an odd function, then integral from negative a to a f of x dx equals 0. So this means, so let's look at an odd function. So again, we know that an odd function is symmetric about the origin. So our function would look something like this. Let's say this is f of x. Now if we are taking an area from, let's say, negative a to a, so we know that since this is symmetric about origin, this area here equals this area, but they are opposite in sign. Since this area here, right here, is below the x-axis, so it is negative area, and this is above the x-axis, so it's positive area. So we have equal area but opposite in sign. So when we add them, we get 0. So that's basically, if the function is odd, then integrating from negative a to a f of x dx equals 0. So let's look at examples. So now if you look at the first function that we have here, so this part of the function x squared is an even function, and this part 3x cubed is an odd function. So we can go ahead and split this integral into two parts. So this equals integral from negative 3 to 3 of x squared dx minus, and then we can keep that constant 3 outside of the integral, and then we have negative 3 to 3 x cubed dx. Now the first function is even function, so if we use that even function property here, we can do twice the integral from 0 to 3 of x squared dx minus 3 times, and then the second function here we have is an odd function, so we know that the integral from negative 3 to 3 of that odd function is 0. So now that becomes 2 times. So if we integrate this, we get x cubed over 3. Then we go from 0 to 3. And the second one just becomes 0. So this equals 2 times. So if we plug in 3, so we get 3 cubed is 27 over 3. Minus, when we plug in 0, we get 0. So this is 2 times 9, and it is 18. So now let's look at the second example that we have here. Let's do the same thing. So let's go ahead and split this into two parts. So we have negative pi to pi cosine x dx minus negative pi to pi sine x dx. Now you need to know the function, okay, which one is odd and which one is even function. So between sine and cosine function is an even function, and then sine function is an odd function. So you probably know that from the graph. The graph of sine looks like that, so it's odd function. The graph of cosine looks like this, so like that, and then it is an even function. So you need to know that in order to use this property. So the first one, cosine, is an even function, so we'll do 2 times integral from 0 to pi of cosine x dx minus sine function is an odd function, so the integral is just 0. Now 2 times the integral of cosine x is sine x. Now we go from 0 to pi. So this equals 2 times, so sine of pi minus sine of 0, which equals 2 times sine of pi is 0 minus sine of 0 is 0. So basically we are going to get, sorry, not 2, we are going to get 0. So this is 0. Now the next thing that we are going to look at is the average value of a function. So the average value of a function f of x and the interval, close interval a to b, is given by this one. So f bar, this is the notation for average value of f, equals 1 over b minus a integral from a to b f of x dx. So just to understand this, we can just take a rectangle here, okay, just to understand this, okay. So I'm going to draw a rectangle here, and then let me say a is the area of this rectangle, and this is the height of the rectangle, which is h, and then this is the width of the rectangle, which is w. So we know that h times w equals the area. And then if I divide by w, then I get h equals a over w, or h equals, I can write 1 over w times a. So it basically means the height equals 1 over w times area, or area divided by the width gives us the height. So it's the same thing here. We know that the integral from a to b f of x dx gives us the area under the curve from a to b. So this is the area. For example, let's say this is our graph of f of x, and then we are integrating from a to b. So basically that integral gives us this area here, okay. Now b minus a is this width. So if we divide the area by width, b minus a, then it should give us the height. But here is not the uniform height, so it is an average height given by this expression on the right hand side of that equation. So that's the idea of the finding the average height of the function. So let's look at an example. So we are given a function here, which is f of x equals 1 over x on the interval 1 to 4. We are going to find the average value of the function. So we already know that the average value of the function f bar is given by 1 over b minus a. So b is 4, minus a is 1, and then integral from 1 to 4 f of x dx. So f of x is 1 over x dx. So that equals 1 over 3. Now the integral of 1 over x is natural log of x. Then we go from 1 to 4. So that is 1/3 natural log of 4 minus natural log of 1. And we know that natural log of 1 is 0, so this is 1/3 natural log of 4. So that is the average value of that function in the given interval 1 to 4. Now we are going to use this average value concept in mean value theorem for integrals. That's the next theorem. So The mean value theorem for integrals states that if f is a continuous function on closed interval ab, then there exists a number c in the interval ab such that f of c equals the average value of the function. Okay, so basically it means the mean value theorem for integrals states that there is at least one point in the interval ab, which is number c, right, where f attains its average value, or it means that there is at least one number, a number, right, c, in the interval ab such that the value of the function at c equals the average value of the function. So if you look on this figure here, so let's say this is the average value of the function, the average height, which is f av. So that is the average height. So in this interval, there must be at least one point where the average value of the function equals to the value of that function at c. So there must be at least one. It could be more than one depending on how the graph is, but we can guarantee that there is at least one point where the average value of the function equals to the value of the function at that point. So let's look at an example here. So we are given a function f of x equals negative x squared plus 4x on the interval 0, 3. And then the first part of the question is asking us to find the average value of the function, which we already know how to find it. So let's go into that. So in A, we are finding the average value of the function, which is 1 over b minus a. So it's 3 minus 0. And then integral from 0 to 3, f of x, which is negative x squared plus 4x dx. Now this equals 1/3, and the integral of negative x squared is negative x cubed over 3 plus the integral of 4x is 4x squared over 2, and then we go from 0 to 3. So that equals 1/3. So when we plug in 3, we get, so 3 cubed is 27, so we have negative 27 over 3 plus 4 over 2 is just 2 times, when we plug in 3, we get 9, and then minus 1/3. Now when we plug in 0, we just get 0. So this is 1/3. So negative 27 over 3 is negative 9 plus 2 times 9 is 18, and then that equals 1/3 times 9, which is 3. So that is the average value of the function. Now the second part of the question is asking us to find a number, any value, okay, c, that satisfies the mean value theorem for integral. So now we know that from the mean value theorem of integral that there must be a number c in the interval 0, 3 such that f of c equals the average value of the function. So f of c means we'll take c and plug it into our function here. So it's negative c squared plus 4c equals the average value of the function, which is 3. So that means we have negative c squared plus 4c minus 3 equals 0. I don't want that negative in the front, so I'm going to multiply everything by negative 1. So I get c squared minus 4c plus 3 equals 0. So we can easily factor these quadratic. So this can be factored as c minus 3 times c minus 1 equals 0, which means we get c equals 3 and c equals 1. So therefore, those numbers, c equals 1 and 3, they both are in this interval 0 to 3. So those are the two numbers that satisfy. So 1 and 3 are the two numbers that satisfy our mean value theorem for the given function on the interval 0 to 3. That's all for this video. I'll see you again in the next video.